Hello everyone, this is data transfer instruction. In a previous presentation, we have seen some of data transfer instruction. Now in this presentation, we are going to study further on this data transfer instruction. Now the instruction is exchange, right? So content of register H is exchanged with the content of register T, and content of register L is exchanged with the content of register E, right? So after execution of this instruction, HL pair content is exchanged with register pair DE. Now let's see an example. Now this is the status of before execution of the instruction, and this is status after execution of the instruction. As we can see here, content of D is exchanged with the content of H, and the content of E is exchanged with the content of L. Okay. Next instruction is SPHL. Move data from HL pair to stack pointer. Stack pointer is 16-bit register which is used to store address of the initial address of the stack, right? So HL pair is again 16-bit data which is copied at SP, which is stack pointer. Now see in this example, initially suppose HL pair is loaded with 2500. After execution of this instruction, content of HL is copied at SP. So after execution of this SPHL, SP is loaded with 2500, which is 16-bit data. Next instruction is XTHL. X stands for exchange, right? So here exchange between two things, right? So first is HL pair. So HL pair content is exchanged with the top of the stack, right? Now what is this top of the stack? Okay. SP register is stack pointer, which is 16-bit register, which is used to store the address of starting address of stack pointer. Stack. Here. So content of L register are exchanged with the location pointed out by the content of the SP, and the content of H register are exchanged with the next location, which is SP plus 1. Now let's see an example of this. It will be more clear to us. Now see here. SP initially loaded with 2700. So our stack pointer is loaded with 2700. So stack is started with 2700. HL pair is loaded initially with 30 and L is 40. So it's 3040. After execution of this instruction, see here, content of this 2700 is exchanged with the content of L, and content of 2701, which is SP plus 1. Here content data is 60, which is now exchanged with this H content. Okay. So after execution of this instruction, H becomes 60 and this 2701 location becomes 30. Clear? Next instruction is PCHL. Now in this instruction, program counter is loaded with the content of HL. So HL content is now loaded into program counter. HL pair, H is one register, L is second register, both are of 8-bit capacity. So HL pair will store 16-bit data, which is now copied at PC program counter. Again, program counter is 16-bit register. See in this example, HL initially suppose loaded with 6000. So after execution of this instruction, program counter is loaded with the content of HL, here 6000. Next instruction is in instruction. Now suppose microprocessor want data from outside of the say processor, then this instruction is used. In this, outside communication is possible through only accumulator. So in 8-bit port address. So in with this 8-bit address. This address is port address. So it defined from where we have to take the data. Data is again 8-bit. Now it is loaded at accumulator. So copy data to accumulator from a port with 8-bit address. Content of IO port is copied into accumulator. Now let's see an example. This is before execution, right? Port 80, where data is 10. After execution of this data, this in 80 instruction, content of port 80, which is 10, is now copied at accumulator. Next instruction is out 8-bit port address. Now suppose we want to give the data outside of the transfer data outside of the processor 8085, then this instruction can be used. Out 8-bit port address. Copy data from accumulator to a port with 8-bit address. The content of accumulator are copied into IO port. Now see in this example, out 50. Suppose initially this accumulator is loaded with 40. So our data is 40, which we have to store at this 50. And 50 is nothing but port address, because this is in out instruction. So 50 is 8-bit address of the port. And thank you all of you.